I will be explaining you Lemma 6.7.1 in this video. You can see the statement here. Suppose that t in a f of v, that is they are given you an element from t from a f of v, okay, has a minimal polynomial. It is having a minimal polynomial over the field f. This is that polynomial and they are saying this polynomial is a minimal polynomial. Minimal polynomial means what? It satisfies t. That is, you will get p of t. In the place of x, you will substitute t, okay. So when you find p of t, the value will be 0. That is what the meaning for t has a minimal polynomial. Okay, you will find p of t, you will get 0 because here p is a minimal polynomial. No, that is what the condition behind it. Okay, suppose further that v as a module is a cyclic module, that is cyclic relative to t. This is important, okay. Using this point, that is v is cyclic relative to t, you will proceed the proof. So that is important. If that's so, if these conditions there, then don't ask me what is cyclic relative to t. Actually, your question is right, but now I am unable to answer. Okay, I have no answer for it. The reason for posting this video is I want to make you feel easy to learn this lemma. Okay, I made it easy, okay, to learn. So that is why I am posting video. When I learn much, if I come to know what is cyclic relative to t, at that time I will tell you what is cyclic relative to t. It is very difficult to tell. Yeah. Then there is a basis of v. There will be a basis of v over the field f such that in this basis, with that basis of v, you can form a matrix that is this. This matrix you have to bring at the end of the proof. Okay. So okay, let's start writing the proof. Here you can see the proof. Okay, right, first line, given t belongs to a f of v has a minimal polynomial p of x equal to this over the field f. This is given in the statement, right? No difficulties in writing this line, right? Just copy it down from the question. And then also given v is cyclic relative to t. Write that also. If v is cyclic relative to t means you can write these. There exists an element that is small v from capital V such that every element, there is another element from V also, that is W belongs to capital V, is of the form. You can write like this form. If V is cyclic relative to T, you can write like this, okay? Don't think that T power R minus 1. That's not. This R minus 1 is the suffix of this gamma, okay? Okay, V is cyclic relative to T means you can write in this form. This W belongs to capital V. V is also from capital V, vector space capital V. Okay. Okay. V is cyclic relative to T means T, no, that is why f of t. Okay, for some f of x belongs to capital F of x. It means the meaning of f of t is you are taking a polynomial. If you take the elements present in this f of x will be polynomials. All are polynomials. Okay, the elements present in this. So f of x is also a polynomial. So here what they mean by this is, in the place of, you will have a polynomial f of x. Okay, in that polynomial, in the place of x, you will substitute t. At that time, you will get f of t. Okay, so that f of t is coming in this place. Okay, can you understand how here you got f of t? Okay, so also given v is cyclic relative to t, there exists small v belongs to capital V such that every element W belongs to capital V can be written in the form W is equal to V into f of t for some f of x belongs to this. Is that okay? Now, if you are taking another one polynomial from this, that is s of x, and saying v into s of t equal to 0. That is how you are taking. If s of x is a polynomial from capital F of x, comma, v into s of t is equal to 0. That is how you are taking. If you take like that, then you are finding w into s of t. So when you find w into s of t, you will get, in the place of w, substitute this value into s of t, and then what you are doing is you are just changing the place of the terms. V into, first write s of t and then f of t. Now you know that v into s of t is 0, right? So 0 into f of t is 0. You will get 0. So you got 0. Thus from this you can say s of t annihilates all of v. The meaning of this sentence is s of t is maps to 0. That is what the meaning of s of t annihilates all of v. That is what our ma'am said. Okay. Thus s of t annihilates all of v. Therefore, you can write s of t equal to 0. You got it, right? After that, what you are doing is, in the statement they are given you, p of x is a minimal polynomial of capital T. Therefore, from that you can say p of x divides our s of x. Okay, from that line you can writing this. You are writing this. Now our intention is to prove v into vt v comma vt comma vt square comma etc. vt power r minus 1 are linearly independent. That is what our next intention is to find. In the first part, your intention is to say s of t equal to 0. Okay. How you are saying that? Using v is cyclic relative to t, you are writing a form, right? And then you will take another one polynomial s of x. Using that you will do something. W into s of t you will find, and from that you will write s of t, and then in between you will write another one sentence also. In the question they are given you a minimal polynomial, that is p of x. So from that you are saying p of x divides s of x. And then our next work is to find, you are going to find whether it is something is linearly independent. That is what we have to prove. What is linearly independent? V comma vt square comma etc. vt power r minus 1 is linearly independent. That is what we are going to prove. To prove that, suppose if it is not linearly independent, okay, that is how you are proceeding. Suppose it is linearly dependent means you will bring the contradiction at the end. Okay, so that is what you are doing. Suppose it is linearly dependent, then this value alpha naught v, alpha 1 v2 plus alpha 2 v2 square, this value is equal to 0 if it is linearly dependent means with this alpha 1 values are belongs to the field f. Okay, that's how you write. Now we get, bring this v outside from each terms, so you will get v into this equal to 0. From this you can write p of x divides alpha naught this values. This is impossible. From this you are getting this. Okay, if your question is how, then seriously I don't know the answer. I'm so sorry, because when you look at my paper you feel the steps, you feel easy. Okay, you don't forget when you write for the examination, but if you look at this, you feel very, very confused. One of my friends also told me yesterday, Divya, can you give me the simple proof of this theorem? It is very confusing like that. Okay, so if you look at this, you will be very, very confused. Okay, but analyzing this, I wrote as little easy proof, but in between some of the steps are really confusing to me also. Okay, my only intention for posting this video is have to learn it. It's an important lemma, so that is why I am making this video. Okay, to make you feel easy to learn it. Okay, hence p of x divides, you will get this, but this is not possible because you are having you already have p of x is a minimal polynomial with the degree what? R. Okay, but here its degree is r minus 1. 1 degree less than the degree having for p of x. So if that's so, then p of x cannot divide what? This. Okay, because the degree difference is there. So that is why which is impossible, since P of x is of degree r. Our assumption is wrong. What assumption? This assumption is wrong. Therefore, these are linearly independent. Okay. And then what you are writing is, since already you have wrote, since W belongs to capital V is of the form, right? Write the same sentence again. Since we get, okay, if that's so, we get this W is a linear combination of this. You already proved it, right? This is the linearly independent. After that, you have to write this. The elements, these form a basis of V over the field F. Okay, therefore, the elements, these form a basis of V over the field F. Therefore, using this basis, you are going to write the matrix given in the statement. So, just copy it down from the question. Okay, this is how you are concluding the proof of this lemma. Can you feeling easy? Is that okay to you? First, okay. Using V cyclic relative to T, you write these things, and then your intention is to find V, Vt, Vt square, etc. Vt power r minus 1 is linearly independent. Okay, you will prove in this manner, and then already you have this. Write it again, and you will say this W is a linear combination of this, and therefore the elements this form a basis of V over the field F, and then write the matrix given in the question. Thank you.